Hello guys, today I'll be showing you how to create SQL Server always on with automatic seeding and read-only routing. So although these two technologies, they are not too much related, but they are small features, so I thought that I can cover it in a single video. So first thing, I will show you how to create always on with the automatic seeding. So normally if we have a 2-node always on cluster and if you're using only always on, there is no problem in automatic seeding. So for those who don't know about the automatic seeding, is that generally when we have the primary replica available with always on, we can add a database on the primary side and it can automatically take a backup and restore it on the secondary replicas. This feature is known as automatic seeding. So we can use it in SQL Server 2017, although I believe it was introduced in 2016. So I'm using SQL Server 2017 with the CU10. Normally the problem is that when we are using SQL Server with FCI as high availability, and for disaster recovery or for any other reason you want to use the always on, by default you cannot use the automatic seeding. And the reason is that once you have the 2-node setup, like for example in my lab I have a 3-node cluster. The first and second node is the FCI node, and SQL Server, the clustered installation is hosting on these 2 nodes. So as of now the primary node is the first one, and the second one is just in a passive mode. The third node is only it will be actually hosting SQL Server Replica. So to use always on availability group automatic seeding feature, we must have the same drive letters for data and log files. So for example, in this lab I have created one drive which is E, and there is a separate folder for data, log, master and DemDB. So this is like not an ideal configuration to host everything on a single drive, but just for the sake of concept, I'm showing you that, for example, if you use E drive for data, log or anything, like for any file which is hosted for FCI, if you add the same SQL Server on the DR side or for the secondary replica, if you start the installation, it will not allow you by default to use the same drive letter. And let me explain you once we start the installation. So as of now we have seen that the lab 1 and lab 2, these are the 2 nodes, lab RR1 and 2. This is hosting the SQL Server FCI, and the third node, it will be hosting the secondary replica, and we have already added that. The third node we have already added in the cluster, and this is obviously normally the best practice to add all the nodes to the cluster first. And if we do this, and we will be starting the installation, so actually inside the installation on the secondary replica, the SQL Server by default does not allow us to use the letter E. I will just go through quickly for the SQL Server setup and just show you the exact error once we have the disk drives allocation. Okay, so for example here the SQL Server setup, actually it shows the error. So for example, by default, if we have to use the automatic seeding, so we have to use the same drive letter, which is in my case E, and in the production system or on the primary replica we will be having the same letter as E and the same folders. So this is the ideal scenario which is recommended obviously by Microsoft, but once we use the same letter in combination with FCI and AG, so it gives us error. So let me just assign the folders here and it will actually show us the error. Okay, so now we can see that it's saying that the SQL Server on WFC cluster cannot have the standalone installation for WFC, cannot have the files on the shared disk. Although the error is not very descriptive, but I also got this situation, so this is the main issue, and there is a workaround for that. So the workaround is to just stop this installation first, obviously, and evict this node from the cluster. Once it is done, then we will again go back to the third node and start the installation again. So in your environment, you can obviously at the start of installation and configuration, do not add the third node or the replica or the secondary replica node in the cluster first. So the workaround is to install SQL Server with the same drive letters as a standalone installation without adding the specific node in the cluster. Once the installation is done, then you can add the cluster the node to the cluster. So now we have just evicted this node, so this is just an independent node. I will start the installation. So here we can easily see that there was no error, and obviously there will never be an error at this point, because now SQL Server is a standalone installation on an independent machine. There is no connection to any cluster, so you can use whatever you want, so there will be no error. Once this installation is completed, so after that we will add this node to the cluster and it will work fine. So I will just skip the installation and I will show you how we will do that. Okay guys, so installation is completed now. So I will just give you the current picture. If we go to the SQL Server Configuration Manager, now we see that the system is not part of any failover cluster. So although we can enable the always on feature because it is 2017, it supports that clusterless installation, but we have to do the cluster installation. Now the SQL Server is working fine. Let me just try to connect it. So for example, if we connect to the system, This is the secondary replica, and obviously this is not available. So now I have to add the third node which I will be adding as a secondary replica, and now we will be adding this to the cluster. Because we already had the all the verifications done, so it did not require that. It is just joining the node to the cluster. Okay, so it is done. I will just go to the system. It is now showing that this is part of the cluster. I will enable the always on feature to restart SQL Server. And that would be all. So in the meanwhile, I will be creating an AG. So let me do that. You have to make sure that we have enabled the automatic seeding here. This is the secondary replica, which is now going to be added in the availability group. Just make sure all the endpoints are configured properly, and that would be all. Automatic seeding. Yep. So this happens when you add the node after creating the SQL Server, so there is no problem. The third node which we added was automatically added in the possible owners for SQL Server resource. So I will just remove this node from the possible owners for SQL Server and press OK, and that would be all. And then again I will try to add the node, and this time it should work properly. So ideally it should be up and running in a couple of minutes. And once we add the database to this system, this SQL Server on the primary replica, automatically it should be replicated, and in fact backup and restore should be done automatically, and it should be added to the secondary replica here. So I will just show you all the configurations. In fact the database settings for both the nodes, it should be same, and to work with the automatic seeding. So here we see that there is small difference, so we will just make sure that it is actually the same. So it should be same. Created a separate folder in the replica, so I will just remove it. Yeah, but there is no requirement for this as of now. Let me verify the endpoints. Why it is not working? So I will just restart the system because the patching was done and I was not able to restart. So once that is done, it should be up and running. Okay, so we have got the connectivity fixed. The issue was with only for the SQL Server service accounts. On one system I was using the local system. So I have configured the service accounts for each service, and the replicas are now connected, and it should be working fine now. So as we have the seeding mode configured as automatic, and obviously we have the drive letters and the path same on both the replicas, so ideally now we should be able to add the database on the primary replica, and like test1 database, just back up this one, and it should be easily able to automatically sync up the database on the secondary replica. So now we can see that there is no database on the secondary replica, and once we add the database in the availability group, it should automatically be synced to the secondary replica and automatically sync. Okay, that would be all. So we will see how much time it takes. Obviously it's like 1 MB or 5 MB database. It should not take much time. It is synchronized on the primary side, and let's see on the secondary replica. Yeah, it is also in the synchronizing mode. So we can see that the automatic seeding, it is a very nice feature, and there is a small workaround needed once we are dealing with the FCI and AG. Otherwise, if we are dealing with only AG to AG replication, like we have configured the AG using a standalone implementation, there will be no problem and there is no workaround required. Okay, so now we will move towards the read-only routing. So for example, if we have configured this this availability group, so we will just need to have endpoint URLs for all the replicas in the notepad so that we can paste it. Okay, so the read-only routing is also very useful feature in availability groups. So all the replicas which are configured as read-only intent, and they are able to read data. For all those replicas, we can configure the read-only routing. And read-only routing means that all the requests which are coming from application with a specific parameter, which is application intent as read-only, so all those application sessions will be redirected to the read-only replicas which are configured. So as of now, the replicas like the lab RR03, it is configured as read-only. Yep. And now we have to configure its URL. So its URL for listener is this one, and for the primary one it is this. Okay, we have to press OK so that it can actually accept the and configure the actual replica URLs. Once that is done, so now we have to configure the routing list. Routing list is an important point in read-only routing concept, because for example, now we have two replicas. One of them will be primary. So as of now we have lab RR SQL CLU 01 as a primary replica for this availability group. So for this replica, which is the primary one, when there is an application which is requesting as a read-only intent, what would be the routing list? So where should SQL Server route these application? So we have to configure that. So we need the secondary replica, which is lab RR03. We will configure this as the read-only routing list. So, and obviously once we are shifted to the second node, the first node should be added in the read-only routing list. So this is the only configuration required for that, and that would be all. So also we have configured the lab RRLST as the read-only the listener for the availability group. So we will just use a third system to test our listener, that where it is actually sending our requests. So for example, if I just connect to the lab RRLST, and the database name is, I believe, test1, and application intent, which is the parameter as K, is read only. Okay, let me add this use. Fix that. Okay, so the listener has to be recreated, and there was a typing mistake for the endpoint URLs. So when we are configuring the URLs for read-only routing, I had to put the SQL Server port, but instead I entered the 5022, which is the listener port. So that was the mistake, it was not able to connect. So I have fixed that. Now the primary replica is labs SQL CLU01, and for that we have to add the secondary replica in the routing list, and for the secondary replica we have added the primary replica as the routing in the routing list. So ideally, if we connect to the listener, so with the read-only intent, so we should be able to actually redirect to the secondary replica. So let's test that. So there is SQL CMD command with the -s parameter as the server name, -d parameter as the database name, which should be in the replica. Without this database name, the read-only routing will not work. And the last most important thing is -k parameter, which is application intent, and as of now it is read-only intent. So we will just connect and see what is the server name we are connected with. So we can see that now we are connected with the listener, and it is giving us the replica name, in fact secondary replica name. And if we just quit this and do not connect with the read-only replica, ideally it should just give us the primary replica name. So there we go. And the other case is that we have to connect with the, for example, if we want to turn off the read-only routing, we just have to remove the read-only routing list. Like for example, this is the primary replica, we will just remove this. This is the secondary replica, we will just remove this and press OK, and that would be all. If we connect with even the read-only routing intent, even then the server should be connected to the primary replica. So with the read-only routing, we are connected with the primary replica. So this is the test, and this is working fine. We can even use the distributed availability groups, which is a new feature in 2017. So we can load balance between multiple secondary replicas. For example, we can add like 2 replicas or 3 replicas as a secondary, and between those we can easily add the easily distribute the load for the read only. So this is the complete lab, and obviously if you need any help you can comment in the video. So thank you very much for watching. Goodbye.